Hi, Wim Dijkgraaf here, Metal Heaven. This is part 2 of an explanation about our JSON format. In part 2, focus is on the assembly subassembly structure. So what you see here, this is the IDA step viewer, and I uploaded this, or I opened this assembly. And now let's have a look at how this looks like in the JSON file. So we have the BOM and then the assemblies collection. We have the project with the BOM node, bill of materials, and then the assemblies collection. In the assemblies collection, a main assembly with this name. And that main assembly has a collection. This is not empty, that you can see here. So this is the main assembly with this name. Are we going to look over here? Then you see the 131400 ASM. Then you see this name, which represents here in the cat viewer the root, which is this thing as a whole. Then you see that this root assembly, so the main assembly, consists of two subparts. And exactly those subparts you can see over here when you open this. We have a subpart named, or a subassembly, that's a better name, sorry. The 13 blah 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 PTL, and that is exactly what you see over here, which means it is everything except this gray part, and the other part is this one, which is this sheet metal part. That sheet metal part is named the 13143, and that should be the other sub-assembly that you see over here. It's the 1314. This now represents this part, which is equal to that. This in the tree, the hierarchy tree, is representing this part. And here we see 1, 2, 3, 4, 5 sub-assemblies. When we open this, we also see 1, 2, 3, 4, 5 sub-assemblies. So if you open up sub-assemblies here, you see the same structure appearing as here. So the 1318 main assembly, the 1318 main assembly, the 1318 here, consists of this one, which is the weld nut, which you can see here and see here highlighted. It has 1, 2, 3, 4 of them. So 1, 2, 3, 4 of them. So this is also a weld nut. And this is instance 0, this is instance 1, and blah, blah, blah. So that's the weld nut, which appears 4 times, 1, 2, 3, 4. And then you see this part, which is the sheet metal part, with the name 1314. You see over here. That's the sheet metal part. So also here you see the same structure, subassembly with its individual parts. Then what is relevant is that collection of subassemblies that is empty. Then this actually represents a part instance. And what is a part instance? A part instance is, so for example, this weld nut. The actual drawing is a boundary representation, a solid, and it exists only once. So there's only one definition of the geometry of such a weld nut. A part instance is actually referring to that one definition, and then there exists a transformation, so it's kind of a clone which is transformed in 3D to have another position. And for example, in this CAD system you see the transformation over here. So this refers to one definition of the geometry itself, and then it has 4 instances of that geometry, with each instance having its own transformation in 3D. That we modeled in Rhodium in a similar way, meaning that the part type is the definition of the geometry itself, and the part instance is where it appears in the assembly structure. And because it's not relevant as part of the quotation software, we don't include the transformation itself. That's really a CAD thing, but has nothing to do with the quotation itself. Such a part instance is referred to here. So that instance has a name as well, and that instance has an ID. And the instance has a financial, as you can see over here. If you look for this ID in the JSON, then you will see that we have a part list. In the part list collection, there is a part type. You see that over here. So this is not an instance, but it's a list of part types. And every part type has a collection of part instances that you see here. And it found this instance over here. And that's also the reason why you see part instances 1, 2, 3, 4, because the part type is the abstract representation of a weld nut, and the instances are all the occurrences of that part type in the subassembly structure. So you can also navigate from here within the assembly structure and find this specific instance. So that's the relationship between subassemblies, within subassemblies the part instances, and then you have the part list, with for every part list a reference to that part instance in the subassembly structure. This is also the reason why the amount is set to 4, because what we actually do is we count the amount of part instances, and that is the amount you see in the financial, the quantity, sorry. So here we have the quantity, and this 4 in the financial is actually based on the number of part instances found in the assembly and subassembly structure. That's all there is about the assembly structure. One missing piece maybe that I haven't explained yet, but maybe is already obvious from the previous video, part 1, is that an assembly is also a BOM item, meaning that an assembly can have labor, and also a subassembly can have labor. And also the same separation between recognized labor, so that is what Rhodium out of the box has found as the working steps that it has recognized, as well as the labor that includes this same collection, but with the manually added labor included. And then of course every assembly has a collection of estimations, and that same thing happens at a subassembly level, where it's also a BOM item, where it's also a BOM item, so it can have its own estimations, etc., etc. So that's it for now, for part 2, with an explanation of the assembly structure and subassembly structure. Hope it is informative, it helps you to really understand how to deal with this structure. See you in the next video. Thanks for your attention.